As we learned in my previous statistics videos, the median describes the middle of the dataset. Just imagine this solid line as a dataset. The median splits its dataset into two equal halves, 50% and 50%. Now today we'll learn how to calculate other measures of location such as quartiles. The quartiles are Q1, Q2 and Q3. Q1 is the lower quartile, Q2 is the median and Q3 is the upper quartile. So if we take a look here, Q2 is the middle of the dataset which is halfway through the dataset. Q1, the lower quartile, is 1/4 of the way through the dataset, that is 25%. Q3, the upper quartile, is 3/4 of the way through the dataset, that is 75% if we look from the lowest value to the highest value. First, let's take a look at how to find the upper and lower quartile for discrete data. Example, the daily mean pressure in hectopascal during the last 16 days of July in city A is recorded. The data are shown below. The data set here is from the lowest value to the highest value and hence there is no need to rearrange. So first, let's find the lower quartile Q1. To find the lower quartile for discrete data, divide the number of data values n by 4. If this is a whole number, then the lower quartile is halfway between this data point and the one above. If it is not a whole number, round up and pick this data point. So, if we take a look at our example, there are 16 data values and hence n equals 16. So, Q1 equals n over 4 equals 16 over 4 equals 4. So, the lower quartile is halfway between the 4th and the 5th data values. So, Q1 equals 1070 plus 1017 divided by 2 equals 1017 hectopascal. Now, let's find the value for Q2. Q2 is the median, so Q2 equals 16 plus 1 divided by 2 equals 8.5. The median is the 8.5th value, so Q2 equals 1019 plus 1021 divided by 2 equals 1020 hectopascal. To find the upper quartile for discrete data, find 3/4 of n. So, multiply the number of data values by 3 over 4. Similarly, to the lower quartile, if this is a whole number, the upper quartile is halfway between this data point and the one above. If it is not a whole number, round up and pick this data point. So, Q3 equals 3 times 16 over 4 equals 12. So, the upper quartile is halfway between the 12th and 13th value. So, Q3 equals 1024 plus 1025 divided by 2 equals 1024.5 hectopascal. Anna records the number of books in the collection of students in her year. The results are shown in this table. As this is an ungrouped frequency table, you can find the median and quartiles the same way you did for discrete data. So first, add all the frequencies together. So it's 95. Q1 equals n over 4. N equals 95. So Q1 equals 95 over 4 equals 23.75. Rounding this up gives us 24. So the lower quartile is the 24th value. The lower quartile lies here, so Q1 equals 37. The 24th value lies in the column with 37 books. Q2 equals 95 plus 1 divided by 2 equals 48. The median is the 48th value, so the 48th value lies here and hence Q2 equals 37. Q3 equals 3 over 4 times 95 equals 71.25. Rounding up gives us 71. So the upper quartile is the 71st value and the 71st value lies here and hence Q3 equals 38. When data are presented in a grouped frequency table, we can use interpolation to estimate the median and quartiles. When interpolation is used, we assume that the data values are evenly distributed within each class. For example, the heights of 50 clover flowers are summarized in the table given here. So, Q1 equals 50 over 4 equals 12.5. The lower quartile is 12.5th value and the 12.5th value lies here. Before using interpolation, let's find the class boundaries for this class. So, it's 95 and 100 as the data has no gaps. The endpoints on the line at the top represents the class boundaries, in this case 95 and 100. The values on the bottom are the cumulative frequencies for the previous classes and this class. The frequency is 5 in the previous class, x is greater than or equal to 90 but less than 95. And adding the two frequencies 5 and 10 gives us a total of 15 up to the class x is greater than or equal to 95 but less than 100. The 12.5th value lies 12.5 minus 5 over 15 minus 5 of the way into the class. So, Q1 lies Q1 minus 95 over 100 minus 95 of the way between the class boundaries. you can evaluate these two fractions into an equation to solve and find Q1. So Q1 minus 95 equals 0.75 times 5. Q1 equals 98.75 millimeters. Q3 equals 304 times 50 equals 37.5. The upper quartile is the 37.5th value and it lies here. So using interpolation, the class boundaries are 100 and 105 and the cumulative frequencies are 15 and 41. So Q3 minus 100 over 105 minus 100 equals 37.5 minus 15 over 41 minus 15. Q3 minus 100 equals 22.5 divided by 26 times 5. Q3 equals 104 millimeters.